This is the one, I guess. About 22 have RSVP, but then I think we'll probably get a whole lot of other people who, or we may get a lot of other people who have not RSVP. Actually, I'll put this down in the front corner here, out of the way. T-shirt.
T-shirt, yeah. There's open the box, so there's a box.
Sure. Yeah. It's funny, the threshold signature talk last week.
Yep.
I knew the content more for that. I mean, I know, you know, we've been involved, having been involved in this for like heading towards 2.25, 2.5.
Yep.
A long time.
Yep.
Yeah, you sort of know a lot of it
yep.
now, but then it's not. There's a huge difference between presenting your own slides to presenting slides that you've in part taken from other people.
Yep.
And you're never going to be able to say the words that they would have said because they'll say it in a very different way.
Yeah, exactly. Yep.
But we couldn't fly Grace over here. You need a combination of people though, because Besu and Plus are sort of, at least that, you know, a lot of the things are done by slightly different people.
Yeah, I mean these slides I think are by committee as well.
Yeah. Yeah. So I don't. No, but they've all reviewed them. So I wrote a good, I don't know, quarter of the slides, and about 3/4 are from other sources. So no one seemed to be too upset with the slides I produced. So. Oh, and I booked this room for next year, and booked in the whole meeting thing for next year. And you wouldn't believe it, but someone's got this room booked for something like October the 14th or something, 2020, for the whole day. And I don't know whether they did it by mistake or not. So I've asked the people downstairs, did they mean to do it? And if so, then I don't know whether we'll find another location, like maybe our office or yeah, October 20. Yeah, someone else knows what they're doing in October 2022.
Is it 2022? Is it?
No, 2020. 2020. Yeah, thinking, oh wait. Yeah. Forward thinking in the blockchain space. Far forward thinking. But I've also said that I'm going to do a talk, the first one back in the new year, on the 5th of February. I'm going to do a talk on how to write cross-chain solidity and cross-chain applications. And I know that feels like, wow, it's getting real when you're trying to tell other people, like, here's a repo, please play with it. And there are a whole heap of samples here, and write your own.
Yep.
We've got a sample code repo, we've got our own Web3J, and we've got our own Besu, and it's a matter of contributing back both of them.
Hello. I feel like you're normally here on Wednesdays, Rob, but I never actually see you. I just see you go backwards and forwards in the corridor.
Yeah.
Oh, you've got a shirt? Yeah.
So there's a box of some things that was particular for, not that I personally packed for putting onto the plane, always personally packed things.
Yes.
That has already been delivered.
I'm going to get a glass of water. I'll be back.
I don't know if there's many of these shirts, but there's the Pegasus. The Pegasus.
Are there any size smalls? Because I feel like I don't know for a chance then.
I think there's a women's small, I think.
There you go. I feel like a woman's smalls are probably not in high demand.
Yeah, it's probably, you probably should be okay on that one, yeah.
Oh, Sarah. People off to the steps. You're not normally here, Sarah. You're not allowed that.
It wasn't going to fit me. It wasn't my first choice.
Plus it looks like Sarah might be close to mine. She doesn't actually report her report.
I was a bit sad we didn't get the foundation.
What was the last good in? What's got so over each one? It's probably clear. I think that's great. She's last time there. Well, the rest of my friends.
But then you've also got people like just trying to tell
Solve the problem check. We're not there.
So you're one of the people who's always sitting in the last 2 hours, right? Yeah, then I'm not.
We're back long problems to deal with.
Yeah. On vacation? Where did you go?
New York.
Did you make it to Brooklyn, Sally? Did you make it to Brooklyn?
I did.
Yeah.
Popped into the office.
Nice.
Said hi to Joe.
Cool.
It's a bit of an adventure the first time you go there.
Yeah.
I was walking along with Grace, so I was actually with Grace, and we walked straight past the front door. And
Not so
Yeah.
I mean, I was thinking, because I met Grace in Manhattan, and I figured that like if we were together, we'd know where we were going.
Yeah, I totally would have missed it.
Yeah.
It's like a street with them. It's like
So,
like you sort of in the area.
Oh, okay.
Yeah, it's other people.
Featured Joe. And,
Oh, yeah, I was going to say we share it.
yeah, it sounds like to me, yeah.
Oh, wow. Things have come to pass.
It's amazing actually looking at very, very
I played golf before today.
Yeah.
I don't really enjoy it.
Yeah. Table, like big boy.
It's quite a skill.
It's one of those times I can feel like that.
No, I like this.
I find that after a while, not the same thing exactly. Just a talk.
Hello and welcome everyone. So welcome to today's Ethereum Engineering Group meetup. Today Rob and I are going to chat about Hyperledger Besu and Pegasus Plus. Before I start, so is it Besu, is it Besu, is it Besu, is it let's see.
Besu.
Yeah. Everyone can work out. So if you're in Australia, Aussie, oi, Besu. But anyway, so you will hear this that word said in many ways, depending on where you are in the world. But for me, it's Besu. But yeah. All right. So I'm going to talk about the Hyperledger Foundation. And so who are they? What is Hyperledger Besu? What's Pegasus Plus? And then Rob is going to take it on from there, talking about the comparison of, so what is the difference between the two. These slides are actually available. So if you look at the meetup, there's a comment, and in the comment there's actually the PDF of the slides. So yeah. And also the video is on live streaming, so you'll be able to see it on YouTube as well. Okay. Who is Hyperledger? So Hyperledger is this umbrella organisation of open source projects that are focused on blockchain and distributed ledger technologies. And so you've got, it's set up by the Linux Foundation, and so it's received contributions from us, Consensus, Pegasus, IBM, Intel, SAP, and so the idea is to have a collaborative effort towards creating these blockchain projects. So that's straight off Wikipedia, though I did add in Consensus and Pegasus. So someone who's got a spare moment and who's got a history of contributing to Wikipedia, could you please update? Maybe we should go up first, given we're the most recent edition. But yeah. So really, it's the world-leading open source collaborative community project, and it's hosted for enterprise blockchain and now public blockchain as well, and it's hosted by Linux Foundation. So there are a stack of projects inside of Hyperledger. So you've got Besu, which is the one that people here in Brisbane in Pegasus work on. Burrow is another EVM one. Fabric is one which IBM spearheaded. And you've got a whole heap of others. Sawtooth, I believe, is Intel. And then you've got these other technologies as well. And I can't even hope to tell you what they all do. So, I don't know, everyone's going, yeah, they're all one Google search away, and then you two will know what they are. Okay, Besu. So, essentially we've got Pantheon, which is the Ethereum client that we've been working on. We've renamed it and we've contributed it to Hyperledger Foundation, and we've renamed it Besu. It's an open source Ethereum client. It's developed under Apache 2 and it's written in Java. You can run it on Ethereum mainnet, or you can spin up a permissioned private blockchain. And it works also on other public networks such as Rinkeby, Ropsten and Gorilla, so the test nets. So Ethereum mainnet, the test nets, or your own permissioned private network. As well as the proof of work used in Ethereum mainnet, you've also got IBFT2 and some other consensus algorithms and features for permissioning and privacy. So why did we choose Hyperledger Foundation as opposed to some other destination for this code base? You know, why did we do this? So Hyperledger, as I said earlier, is the world-leading open source foundation for blockchain and distributed ledger technologies. Being part of Hyperledger allows us to do cross-pollination with the other Hyperledger projects. And also it should allow us to grow our business. There are some companies where they've said, look, we're only going to use blockchain projects that are part of Hyperledger. Hyperledger, they've done more vetting, or there's some magic pixie dust, essentially. But so there's some level of thought within some companies that let's just use Hyperledger. And so hence being part of Hyperledger enables those people, those companies, to use this code base. And another thing to think about is there's some really smart people, some really top-notch people who are part of Hyperledger, and essentially we earn those custodians, so they become part of our project, and they're able to contribute, and so that's actually pretty good. And also another thing, this is more a benefit for Hyperledger, not so much for us, but for Hyperledger at the moment, they're only permissioned private blockchain or distributed ledger technologies, whereas we're suddenly saying, hey, here is a public blockchain, so an Ethereum mainnet, but a public blockchain technology, which is something quite different and something that Hyperledger doesn't currently have. So who are the maintainers of this open source project? So initially, the maintainers are people within the Pegasus team who've got a history of contributing to the actual Pantheon and now Besu code base. So they've got to have done, I think it was 5 or 6 solid pull requests. Over time, people who have got a strong history of contribution, so who aren't part of Pegasus, can become maintainers of this software. And so we openly, yeah?
I was going to say, we actually just, we had a proposal for it, and it was accepted after the appropriate time yesterday of our first non-Pegasus maintainer.
Okay, cool. And so, yeah, so it, I openly encourage people to look at what code is there, look at what issues there are, consider either adding new issues and new pull requests, or doing a pull request based on an open issue, and contributing. And you could head towards becoming a maintainer of this system. Yeah. So what repos are out there? So it's in github.com Hyperledger/Besu. So all of the Hyperledger code is under that user group. Our docs also are under a different repo, Besu docs. To communicate with the team, We're using Rocket Chat. So Rocket Chat is the way of communicating and, say, asking questions if you're interacting with Hyperledger projects. So when we've moved to Hyperledger, there's been some things that we've had to, say, change from what we've been doing. So I think historically we're using Gitto a lot, and so now we've moved to using Rocket Chat. And you'll find as well, when we've got engineers, say within Pegasus, who are developing stuff for Besu, they'll be talking on the contributors and the main Besu Rocket Chat to discuss their development. So the development is happening in the open, in the public. And so if you've got questions that you want to fire through, Richard, then this is a good way of getting them in and having people see them. As well, the meetings and the calendar are public. So there are. How often do the meetings happen?
So the contributor meeting happens every fortnight in 2 different time zones. So we have the one that happened yesterday was Australia and West Coast US friendly, so it's about 11 o'clock our time here. And then there is one in 2 weeks' time that'll be Europe and US East Coast friendly.
Mm-hmm.
And that's for the contributors to basically bring up the things that are being done in the code base, potentially events that are coming, stuff like that. So at the moment we only have the one meeting, which is the contributors meeting, but as we grow up with the community, there will be a community meeting as well, which will be more focused around showing how to do things or answering questions people might have, but at the moment we only have the one.
Okay, cool. All right. So Brett's obviously the go-to person for contributor meetings.
I host the Australian one.
Okay, cool. So, and then the next one will be in 4 weeks' time. Yesterday, that may end.
Tuesday 11 Australian time.
Yeah.
But the calendars, as you said, are all up there. The meeting notes are available, recordings of the previous meetings are available as well as the agenda.
Mm-hmm. Okay. Okay, so that was Besu. So what's Pegasus Plus? Well, that's the logo. So within Pegasus, we're Pegasus, as you know, we're a business unit within Consensus. And so within Pegasus, we're working on a whole stack of stuff. So we've got Hyperledger Besu, which is the underlying Ethereum client, which does mainnet and private. To do the private transactions, you need a private transaction manager, which is separate, and so you can plug in anyone you like, but the only one that exists that you can plug in at the moment is Orion. You know, I'm looking around at people, scanning the audience to have people correct me when I'm wrong on this little small piece. Eth signer. So some Ethereum clients, they have essentially your private key and a public key. So if you're an externally owned account, you can actually have the Ethereum account keys managed within the Ethereum client. And so I think there are account services, for instance, you could have. So when we were putting together Pantheon, now Besu, we took the view that having your keys for your account within the actual Ethereum client, so on the node, was actually a bit of a security issue. And so hence the keys aren't in there, but you can set up a separate Eth signer instance which will hold those keys, so that can be separate you from the node and allow you to do signing of your transactions separately. So these are still open source, so that's something to consider. So we've got Pegasus Plus is extra components on top of that. So in addition, and in the next slides I'll talk about Pegasus Plus in more detail. In addition to all of them, we've got Artemis sidechains and zero knowledge privacy library that we're working on. So Artemis is our implementation of Ethereum 2.0. And so I know Brett's actually done a few talks on Artemis and on Ethereum 2.0 and what's happening there. And Adrian, who's not in the room at the moment, is actually working on. Some people just came into the room, but they were not Adrian. Anyway, but I believe he's actually working on that. So we're, as you all probably know, we're busily working towards actually having that go into production sometime in Q1 next year. Sidechains is the stuff that I'm working on, and the team that I work with are working on, trying to allow you to do ephemeral, on-demand blockchain, sidechains, and also cross-chain transactions, with the hope that the cross-chain transaction piece will be available as an experimental feature sometime in Q1 next year. And zero-knowledge privacy is trying to do on-chain privacy to do zero-knowledge execution. And I think that's a bit further off into the future. So Pegasus Plus, and licensing and more. All right, so what we've got with Besu is it's open source, whereas the Pegasus Plus side, it's closed source. So it's a commercial distribution. So Besu, where you're going to have free training, so there's read the docs sort of stuff, and other free documentation. Whereas on this side, you're going to have support. So rather than having to try and support yourself by reading the docs and generally a community support, you'll actually be able to contact people, and we'll get back to you in a reasonable time frame, in a finite time frame that you'll pay for. And so this is a paid for model. And also there is the potential, like if you say, hey, there is this feature that would be fantastic if it was actually in Pegasus Plus, then you could help us develop that roadmap, and we could develop that feature. So it could help you influence the direction in which we go. So, to summarize, a commercial distribution that contains additional features over and above what Besu contains. Closed source, not open source. If you want to communicate issues and discuss with the team, you'd be sending emails to info@pegasus.tech. And support would be via email and Zoom video calls. Okay, the comparison, over to you.
Okay, so I've got a collection of slides that hopefully I'll be able to talk to in a coherent way. But really the things I'll be talking about are the mix of Hyperledger Besu, Pegasus Plus, what they are, what some of the differences are, some of the roadmap going forward as well. So Besu, feels like marketing. The most advanced Ethereum client across public and private chains. So I think toning that down a little bit, making it a bit more real for Aussies. It is a good Ethereum client. That mix of I think it's one of the best with that mix of public and private chains. So you've got in the private space, probably one of the leading clients would be, in terms of Ethereum, would be Quorum. But Quorum is probably not something that you're going to use for the mainnet. When you think about mainnet, probably the leading client at the moment would be the Geth, so Go Ethereum, and of course it doesn't actually work to have any of the privacy sort of features. So the privacy features, the three Ps, where one of them is not really a P, but the three Ps are privacy, so being able to control who has access to information, permissioning, so being able to control who can actually connect into the network at all, and then the performance or consensus mechanisms, fast finality is sort of the things that get talked about in terms of the main things for enterprise Ethereum. And so those are all things that we have good answers for, and I will probably be talking to in later slides, but I might not, and if I don't, you should ask me if you care. So I guess the other thing then, when talking about Pegasus Plus and Hyperledger Besu, Hyperledger Besu, our open source client, is always going to be a enterprise Ethereum there's a enterprise Ethereum alliance. So our goal is, as soon as the EEA comes up with the compliance test suite, Hyperledger Besu will be one of the early clients to be compliant with it. The open source software will always be a enterprise Ethereum sort of client. So the Pegasus Plus is going to add things that make it work even better, but it won't be taking functionality away from that core client. So Pegasus Plus, like the words say. And I'll just let people read. So the three features that are there are database encryption, so encryption of the state database at rest is the first feature. The second feature is advanced monitoring, so that's around the IBFT2 consensus mechanism, so being able to get better insights into that. And so there's a slide talking later on, but overall within our monitoring, we have Prometheus, and so we use Prometheus to expose a whole bunch of metrics around our client, and so we have some additional metrics that are available if you use the Pegasus Plus. And then the third one that's there is event streaming, and so an Ethereum client exposes a bunch of events and information. Currently, the way that you sort of get access to that is through either polling a JSON RPC or subscribing to a WebSocket. So sort of looking at that, it's actually something that you probably really care about in an enterprise context, and so you want more reliable messaging, and so that's why we've made that available through Kafka and Kinesis sort of subscriptions. It's not officially supported, but there's also an implementation. So the guy who was building it thought, I did two, I'll do four. Make sure that it is actually a very generalized solution, and so he's also got implementations for there's NATS, which is the cool Go streaming, and RabbitMQ, which is the more sort of older enterprisey sort of one. So making sure that we've got that sort of wide range, and I guess it's sort of the sort of thing that once you've got that breadth of support for event streaming, there's lots of different ways that you might want to do it. So we've done enough that we're confident that if there's another one that comes up that someone cares about, it's easy enough to do. And I think the overall within Pegasus Plus, as Peter was saying, it's very much around this a production quality software that we're really happy to support and provide those first class services around. Here's our roadmap. We are sort of about here, I think. So just about to release the Pegasus Plus. I think the release candidate for that went out today. It was created. Looking at the body language of people, they're seeing that's true. So some of the big things that are there in the past, where we are now. So clearly the very first thing that's not there at all, but is most important, is we work well on mainnet, and so we support Ethereum and all of the forks and hard forks and milestones that have happened along the line with it. On the privacy side, so we've got the private permissioning sort of framework, which I'll talk about in a little bit. We've got some really great permissioning, so being able to control which nodes connecting to a network, which accounts can submit transactions. The IBFT2 consensus mechanism, which is based off of an earlier IBFT consensus mechanism, probably not surprising, and other sort of features to make it work really well. I think it's definitely worth talking about some of our deployment, and so we would take sort of making it easy to deploy and run in enterprise settings as a really important part of our offering. And so we've got support for Docker, Kubernetes, and Ansible. And then the key management, external key management, eSigner. And so if we look sort of to the future, sort of around here, you can sort of see that our eSigner work that we've got at the moment is something that we can see is going to be worked on and improved upon as we go forward. Our current release, so we talked about some of those Pegasus Plus type features. They were the big things that we've been working on over the past few months. The 1.4 release, as we look forward, is going to, I think, be another sort of incremental sort of release, tying up some extra loose ends around some of those features and making it an even more robust and high quality product. The big thing that's kind of there is flexible privacy groups, and so when I talk about our privacy stuff in a slide or two, I'll talk a little bit about what that means. And so that 1.4 is scheduled for February, end of February next year, and then we've got another sort of ongoing series of releases. So our release schedule that we sort of loosely follow to is about every 3 months for a release, which ends up sort of stretching or shrinking a little bit based on seasonality and Christmas and DevCon sort of means that you want to release something for DevCon is important. So, you know, it's about every 3 months. And then within that, then every 2 weeks we do a point release to sort of keep on doing that continuous delivery of our software. Almost continuous, like it's software, so there's versions. But and then, yeah, so I guess there'll be those ongoing releases mid-2020 and beyond. Somewhere between February 2020 and 2021, there'll be a version that gets called 2.0. And that'll be talking to marketing and various people to just pick when the appropriate time for that to happen is. The challenge around that is, a part of the challenge there is there's Ethereum Serenity, the next major sort of milestone of Ethereum, which often gets called Ethereum 2.0. And so there can be a little bit of confusion on Hyperledger Besu, our Ethereum client, being at 2.0 when maybe the protocol isn't at 2.0, but we'll see how we go with that. Oh, and I've managed to be still for too long. It works much better with Peter's fingers than mine.
As far as you know.
Yeah. Okay, so I'm going to do a bit of a deepish dive into some of these features, and talk to how they work. I think I've got lots of time to talk, so I'll keep talking. So the first one is the privacy support, and so within Ethereum and Enterprise Ethereum, there's a whole bunch of different ways that you can think about privacy and do it. You can do I guess encryption type techniques and keep it all on-chain and use, I guess, either zero knowledge type solutions or some sort of secret key that you've got to help keep the data secure. Or you can use what we've got within our system is a restricted privacy solution. And so what happens with that is that the private transactions are not actually kept on chain. Instead, the thing that's kept on chain is a pointer, so a hash of those private transactions. And so that sort of private transaction manager approach is one that was used and implemented in Quorum first. We've taken that approach and done I think there's an incremental improvement and a couple of improvements on top of that, added in a couple of other extra sort of useful concepts. The first of which is the privacy group. So this is the high-level architecture of what the privacy solution looks like. So an application will submit a private transaction to the JSON RPC endpoint inside of Pantheon, or Besu, not Pantheon. It'll submit that private transaction to Besu. Besu will then take it, give it to a private transaction handler. The private transaction handler will then interact with Orion to distribute that private transaction to the other Orion nodes that are involved in the private transaction. So we can see here we've got a single Orion that's sending it to a single remote Orion. The private transaction involved a number of people who would send it all out to all of them. Having distributed that transaction, it will receive a hash back. That is the marker for that transaction. It'll write that transaction to the public state of the chain against a precompiled smart contract. When the transaction processor is going through and processing that transaction that's written to that precompiled smart contract, it'll then go to detect that it's for a privacy precompile. In the privacy precompile, it will then interact and execute that private transaction and keep the state against the privacy group. So there's three things that are sort of important things to think about with this. The first is this idea of a privacy group. So the privacy group, you can either specify an explicit privacy group that you've created with the list of participants, or the system will implicitly derive the privacy group based off the list of participants. When you're sending the transactions to the privacy group, the state is stored against that privacy group, and so is kept sort of in sync across the people, and people will have, in the privacy group, will have that same kind of state. The second thing that's interesting here is this transaction, that's the market transaction, is done against as a standard Ethereum transaction against a precompiled smart contract. So that's interesting. I think that's pretty interesting for a couple of reasons. The first is that it means that because that transaction against the precompiled smart contract doesn't update any world state in the public state, it means that this type of solution would work in a mainnet world. As long as the parties that are involved in the private transaction are all running an Ethereum client that knows about that precompiled smart contract, the other people that are not involved in that private transaction do not need to be running a client which is running that knows about the smart contract, that precompiled smart contract. And so that means that this sort of solution would work in a mainnet kind of world. David?
So it seems to me from what you've described that you could do that today with Besu on mainnet if the other parties in the remote transaction were also running Besu. Is that a true statement?
That's a very, very close to true statement. So that's true based off the information I provided.
Yeah.
The extra bit of information is that for the private, this state that's stored for the privacy group, at the moment the implementation detail is that does not handle chain reorganizations very well. And so once that implementation detail gets sorted out, your statement would be true that this could work in a mainnet world, and you can deploy.
That's interesting.
Yeah.
So what does it do when a transaction comes through that's a private one, and my node being get on mainnet doesn't have the private precompile?
It's
not going to break.
It's not going to break. So it will send the private transaction to an address which doesn't have any code deployed, and the behavior of Ethereum when there's a transaction that's sent to an account that doesn't have any code deployed is to no op and do nothing, and to keep on going ahead.
Is it no ops?
What happens if someone maliciously deploys a contract to the address?
You'd end up in problems.
Yeah, okay.
You could end up in problems there. So you could, to protect against that sort of scenario, you could deploy a contract which does nothing to that address.
Yeah, that's probably the way to
Would be the way to potentially work around that.
explicit no-op instead of implicit no-op.
Yep.
Yeah.
Okay.
The private transaction handler, is it stored in a mainnet compatible way, or how is that actually stored?
So what it does is it does the work. So this is here. It sends a transaction to the public state against against the precompiled smart contract, and so the way that it does that and writes that transaction is in a mainnet compatible way, or is in a standard Ethereum compatible way.
I think the piece that is mildly confusing the diagram is it looks like all that happens in one go, and in some ways I guess it does, but the transaction processing over there is separate to the private transaction handler, right? Yeah. So the remote client on that side gets the private transaction. That doesn't go through the private transaction handler, that goes through the transaction process, because it's a transaction out on the net. That's my understanding.
Sorry, one more question. So
lots of abstractions, so there's a lot of detail hidden beneath. There it is.
Well, I would hope so. The JSON RPC call
Yes.
that's associated with this, is that currently bespoke to Besu?
Yes.
Or is it, how aligned with it, is it with intended EDA standardization?
So we have two different endpoints. that are used with it. One is EEA compliant, but is not fully featured, and the other is our extension to that, which is our own endpoint, because the way that the EEA client specification is written, any time that we use the EEA namespaced methods, we need to be fully compliant with the way that it works and not have any extensions to it.
Yeah, right. So, are you, what's the delta there? What can you, if Quorum were to implement that call in an EEA compliant manner, how much of this could they accomplish?
There's significant work that would need to be done to come to consensus on what an EEA compliant privacy solution really looks like.
Yeah, I believe that.
For interop.
Yeah.
So there's two spots that would have to be done. So the agreement on how you write those market transactions need to be achieved. So that's the first point, and then the second point would be the communications protocol between this and others would need to be agreed as well.
So the current position then would be that's something that Pegasus hopes to work out with other enterprise Ethereum implementers at the EEA testnet in due course.
Yes, and I think to strengthen that position just a little bit more, Pegasus is still innovating heavily in the space and working out what our APIs look like and how to do that well. Once we get to a spot where we're confident that the APIs that we have are solid and robust and approximating the right direction, then it's worth doing that standardization effort. But at least my perspective, so I shouldn't say Pegasus' perspective, but my perspective is that we need to get to that spot where we know, we feel confident that we're doing things right before it gets standardized.
Well, you're being recorded and it's going to be on the internet, so you might as well represent the company.
So our privacy solution, just to come back around again, so there's the privacy group. So the privacy group is something that's not in the EEA specification, and so that's the key difference between the Pegasus specific privacy API and the EEA one. Is it talks about privacy groups. The transaction that we've got against that pre-compiled smart contract, I think, is a really kind of cool thing. The other thing is this state that we store, and keeping separate state for each of the privacy groups helps move to a spot where you actually need to be communicating with that whole privacy group as you sort of work forward with the transaction.
Isn't there an important feature of the whole thing that the current EEA thing, you've essentially got a fixed set of nodes that are going to be in a private transaction, and so that could be deploy a contract, do stuff. Then if you, at some later point you say, hey, wouldn't it be great for there to be another node involved in all of this, then you're in trouble. You know, there's no way of doing it. Where with the privacy group, you set up a set of nodes that are going to be part of something. You get an ID that represents the privacy group, and then at some later point you say, actually, we need this other company to be part of it. So we add them essentially to the ID and essentially expand the privacy group.
Yep.
So that's the real value add, I think.
That's right.
Or to remove someone from the privacy group as well.
This comes up all the time with external auditors.
Well, yeah.
Right? Where post facto you want to add an auditor to a list of transactions between banks or what have you. And so this is an important feature. We've come across this in our interviews to the market really regularly when people say they want to have that.
Yeah.
Is that 1.4? Is that in 1.4?
So that's scheduled for 1.4 and is being actively worked on. So the add and remove definitely is a piece of function that we have known we need to have and has been sort of worked on actually since we came close to having a version of it in 1.3, but we also know that it's a feature that we want to get right. And so we did a design review and sort of came to a spot where we said, no, actually this isn't the right solution to have iterated on it, and it's on track, I think, at the moment for 1.4. So that privacy group and adding and removing members from the privacy group is definitely one of our features for the 1.4 release. I am going to hand the laptop back over to Peter.
Oh, Pete.
He's going to use his finger again.
Ah, sure.
Yep, and we will keep moving. Got double moved. Okay, so I suspect that was the longest slide that I'll talk to, but we'll see how we go.
Challenge accepted.
The next feature that we want to highlight is permissioning. So permissioning is, and in terms of how we are thinking about it in this context, is controlling who has access to the network. And so there's two different ways that we talk about it. So the first is an account level, so who can submit transactions, who can interact with the JSON RPCs. And then the second is around the node level, so at a peer-to-peer level, who can connect into the network. And so we have a smart contract-based permissioning model, and so it's actually, I had nothing to do with the design, so I can say this, it's actually pretty cool. And so there's two elements to it. So the first is a well-defined interface for the enforcement of the permissioning, which the client will sort of interact and check at runtime to say, is this account or node allowed to interact in the way that's specified? And then the second sort of part of it that I think is actually the cool thing is that allows you to have a different models and approaches that you use for the governance. And so at the moment it's just, we have a very simple implementation, which is just admins able to add or remove people from a whitelist. As we move forward, we can see that there's potential where you might want to vote on who's allowed to join the network, or maybe have some sort of role-based access control. And so these sorts of things are all enabled by the sort of good split that we've got between that enforcement implementation and the enforcement runtime sort of well-defined interface, and then the implementation of that, which you can sort of change it at deployment time. That's our permissioning. There you go, I was quick.
I believe.
Oh, there we go.
No, I was going to say, I believe a couple of meetups back, was this one you did, Sally? We went into the details on permissioning.
Yep.
So if you go back to the YouTube channel, you'll find the details, a lot more detail about that.
Do I tell any lies? No?
You stayed high enough level though.
Awesome. It's always a good way to go. Okay, so the next one is the consensus protocols. And so the sort of different ones that we've got here, so the classic kind of proof of work that lives on the mainnet Ethereum. We have an implementation of the click proof of authority, and then the IBFT 2.0 proof of authority, which is a BFT sort of really robust consensus algorithm. So when we look at the sort of list, we think that Fhash is what you use for the main nets, and if you're running in a private consortium, then you probably want to use IBFT2. The click is kind of one of the things that we did on our way to getting that IBFT2 sort of implementation done. We don't really recommend that you use it unless you're joining a consortium which is already using it.
Isn't it also used on some of the test nets?
And it's also used, yeah. So it's used on the Gore League testnet.
Yeah, it recommends.
Okay, so our external key management at Signer, I think we've already talked a fair bit about it. So the different things that we support for storing the keys at the moment, the file system sort of based approach, so that's using the sort of standard key store that's there. HashiCorp Vault or the Azure Key Vault. And so it acts as a pass-through proxy type service, and so you sort of configure your dApp to interact, and instead of having the Ethereum client JSON RPCs, you point it at the eSigner. eSigner will then just pass through everything that doesn't require any key management. Anytime that it needs to sign a transaction, it will intercept that, do the signing, and then pass it through as a signed transaction to the Ethereum client. And yeah, so that's kind of how it works, and it's Ethereum client agnostic. David.
So from a cybersecurity perspective, the presumption here is that the connection between the dApp and the Ethereum client is SSL encrypted, and then this transaction is unsigned within the runtime of the Ethereum client, in between the Ethereum client and the eSigner.
When you say Ethereum client,
You said Ethereum client's on your goddamn slide. Don't push that off on me, that's you.
no, that's all right.
First line in bold.
Yeah.
Yep.
Okay, so within those, so there's three things. So if we say dApp up the top,
Uh-huh,
Ethereum client down the bottom,
uh-huh.
eSigner in the middle, your dApp will interact with the eSigner, and it would have unsigned transactions going in. The eSigner would sign the transaction, and the Ethereum client would only ever receive signed transactions.
Can you go back a couple of slides? Is that wasn't represented that way?
It's not on here at all.
No, back further. Go. Could have sworn I saw a slide of this. Right there. I guess it doesn't actually say. All right, fine. Yeah. All right. So is there, what's the network connection between the dApp and the eSigner?
Yes, I don't have the right answer. The right answer as of 1.4, the recommendation would be it's a HTTPS, TLS connection, and the sort of goal will be that there'll be TLS sort of all over the place.
Right. Okay, thank you.
And yeah, so within the current version, it maintains a single key. As we move forward, it would be maintaining multiple keys. The other thing that will be happening as it goes forward is probably looking at some sort of authentication around it. So that you can do like an OAuth or Auth0 sort of connection that is authenticating and passing your identity through. And
So
then,
right now, every account has its own eSigner associated with it?
yeah.
I see.
Yeah, and so there's I guess a roadmap of extending the eSigner to provide that mix of ease of use while still providing the security that we need, or as much security as possible when you've got a component which is holding multiple keys.
Component end up looking a lot like a run.
No.
Key management, it's not privacy management.
It's not private transaction, it's the key management.
Doesn't a run do key management? Not at all. Okay.
It does a single key, which is not an Ethereum key.
Yeah.
There is a concept in Ryan which account is used to send the public market, transaction, but not the key management.
Yeah, I see. Okay.
So one of the things then that we've been, I guess, leading some of the development of is there's a GraphQL interface into an Ethereum client, and so that's supported by Get and Besu, and so I think it's got two parts to it. One is I guess making it decreasing some of the overheads maybe in sort of interacting with the client. More than that though, it's actually a really nice API for interacting with the client, and particularly for querying, looking up information. So it's complies with the normal GraphQL kind of standard, so all of your GraphQL kind of development tools work well with it. And so GraphIQL, I don't know how you pronounce it, but that is kind of a nice front end for interacting with GraphQL, and it's just the nicest way actually to explore and play with things. And actually, so it's specified in 1767, the interface, and so we comply to that. So monitoring, so our biggest thing that we've been doing is sort of doubling down on Prometheus, and so using that as our way of exposing information. We have done that pretty disciplined way of having a metric interface that is implemented in the client, and so it's the sort of thing that if there was some other monitoring standard that someone really cared about, it's not a hard thing to implement. So we've got some Grafana dashboards for working with it and looking at it, and it sort of seems to work pretty well and give a decent visualization. The other thing is we've also then, so within the metrics that we expose, some of them are kind of client specific, some of them are kind of the general metrics that you'd care about for any Ethereum client. For those that are generic, we've contributed an heap to try and get a standardized sort of way of people doing it. Deployment, we talked about earlier, Ansible, Docker, Kubernetes. The Ansible is probably the way that if you're choosing right now, it's probably the way that we suggest that you lean towards. But if you love Docker and Kubernetes, we play with them as well. Looking at time. So I think I've talked about a fair bit of this. So it's the monitoring, the event streaming, database encryption are the key things. The flexible privacy groups, I think, will actually probably mainly be in the Hyperledger Besu, more so than Pegasus Plus, just where it's going to fit. And then we'll be doing some more contract commissioning, so those advanced sort of features that I talked about before. So our monitoring, I think I talked to this a little bit already. So it's very much around the IDFT2 sort of stuff. So it's adding in the actual extra Prometheus metrics specifically around IDFT2. I think there's a couple that are implemented now and a couple that have been sort of identified as maybe some extra ones that will be added in the future. And it's again just for helping you to understand what's happening with your network. The event streaming, these are the things that we're seeing, and actually it's one of the features that people have been most interested in. So I'm not going to talk to the marketing slides, but it's all about actually, you want to get what's happening in your blockchain, actually being able to get that out into the rest of your enterprise systems, and being able to get a really good, reliable information about what's happening into the rest of your systems. Encryption of data at rest. That's a thing that you probably want to do, particularly in a private network.
What's the date on that?
That is October the 25th.
Oh, it's like, alright.
So it's in the, so sorry, these advanced monitoring, event streaming, and database encryption are all Pegasus Plus in the release that's happening next week.
Thank you.
Would you like me to talk to this one?
And Peter will take over and talk to us about what's coming.
Okay, so thank you, Rob. That was really good. I'm glad you presented those slides because I don't think I would have done a really good job. Okay, so Babu is coming up from the Gold Coast. He's Griffith University on the Gold Coast, and he's going to be talking about what he's doing research on. So that's going to be interesting. Digital blockchain, digital assets.
So that's blockchain digital assets, not digital assets, the company.
Yes. Yes. Yes, exactly. Very true. So I think it's an analysis of the types of things that are in a types of assets within a blockchain system. Anyway, he'll tell us more. Horacio, who's up back there, in 4 weeks' time is going to talk about precompiles and JSON RPC calls and how to write your own and how to add them into Besu. And then David, who's been the person who's asked all those tricky questions, is going to be talking about IoT two-factor authentication using blockchain.
See you on the 27th.
Yes, see you
And then I'm going to talk about Ethereum reals, forks, and selfish mining, and talk about that. And then we're all going to have a Christmas break. Whereas 2 weeks after the 11th would be the 25th, and not many people would be there then. So, in fact, we figure that a lot of people during school holiday time it's really hard. So we thought the 5th of Feb, everyone should be back. And I'm going to talk about how to write a application that uses cross-chain transactions, and talk about the DApp and the Solidity code. And we're going to walk through some use cases and some actual code that does that. And which means that the sidechains team, which is developing this technology, is going to be under the pump to have it all ready by February the 5th. Yeah. So anyway, are there any questions for Rob or I? Okay, well, brilliant. So thank you everyone for coming along, and have a great fortnight. See you later.